Hello and welcome. Today we're gonna continue on that topic we started I think 3 weeks ago. We're going to be discussing clustering using the K-means machine learning model, and then we're also gonna use Kafka, Vertx for creating the application calling on the Google API. So as you can see from my screenshot, this is the intended outcome. We've got a set of data points that is coming from data generated for Uber Johannesburg, specifically for the trip between Sandton and OR Tambo. So based on the data we have, what we want to do is we want to be able to cluster all the vehicles based on where they would be at a particular point in time. And as you can clearly see, I have the cluster labels on the markers here. So this would represent a particular car cluster that would have been generated from the machine learning model as the data passes through that. And on the same map, what we've done as well is I've plotted the heat map. So based on the intensity of how many vehicles are sort of in that region, you would get the color intensity changing over time. The only other thing that we did here is I just changed the default Google Maps layer to show us the silver sort of type of view, and then I've also given control of changing those kind of layers as well. So if you go here to my right, you will see that this is the data that is being represented as it is being pushed through. So we've got a base, the cluster ID, the date, latitude and longitude as it would be. So as the data points are passed through, we're also counting how many sort of vehicles are in that particular cluster, which then informs our heat map. And here you can see we've got the cluster ID. So for each cluster ID, as the numbers increment, you would see that the numbers would also increase, which like we said before, informs the heat map. So I think maybe let's just go straight into it. What I will do is I will start the application first, and then after that what I will do is I will then go into the explanations of how we are building this. So I'm just simply going to start the application on my machine on port 880. This port number you can change depending on what port is available on your machine. So because the application is started, I'm just going to go into my Explorer. As you can see, we have started the application. There is no data that is coming through right now because I haven't started the process of pushing the data. What I'll do is I'm going to change to the silver layer as we had in that image, and I'm also going to turn off traffic. I'm going to turn off transit. So essentially for this one, I wanted to be able to just see the data points without showing the traffic, but it's also important sometimes. For instance, depending on whatever use case you have, you might want to see where your vehicles are in relation to how the traffic is. So for maybe for city planning purposes, or just for if companies just are interested in terms of knowing where their vehicles are and what could impact, say probably if it's a delivery, or just knowing exactly where their vehicles are. The same thing with weather as well. You might also want to know in relation to the weather and where your vehicles are if your drivers. So for instance, I know in South Africa we've had a lot of hailstorms. If the weather is indicating a high probability of hailstorms, you want to maybe probably warn your drivers to get off the road, or maybe find a safer way of getting to the destination without endangering themselves. So what I'll do now is I'm going to start the process to push the data to the map, and then we will take it from there. So I'm going to explain everything that we're doing here in a later in this video as well. So the data is coming through. We will see it reflect just now. So as you can see, it's already starting to plot the data on my map. I'm just going to move it around so that we can have better visibility. I'm also going to show the developer tool so we can see exactly what's going on our data as it is coming through. So as you can see, over time, as the data comes through, we have plotted our clusters. So this is a once-off thing that we do at the beginning, coming from our machine learning module. Like I explained before, we're using k-means, which is a basic clustering based on the nearest point. So it elects sort of one of the points to be like the cluster. So as it is, you can see the data is coming through, and the map is definitely changing, reflecting the changes that we can see in the data as it is coming through. I'm just going to zoom in closer so we have better visibility of what is going on here. Alright, so maybe I think for now what I'm going to do is I'm just going to stop this and then try to explain a bit what we are doing here. So basically we have a machine learning model that we've created. Maybe let me begin by showing the data. So this is the basic data that we're pushing through that model. You can see we have a date, latitude, longitude, and a base. So all we want to do is when we submit this data into through our model, we train the model, and once we've trained the model, it sort of estimates what the clusters would be based on that. So like I explained before, clusters is just picking the central points based on the number, which is the k that we provide. So we could say we want to have 5 clusters, we want to have 10 clusters. So based on that, it will go through the data that you provide to it as a training data set. Once it has gone through that, it will estimate the location of what each cluster would be, which is essentially the nearest location for the points based on the value that you provided. So I think one particular use case for this, I know Uber is already probably doing this, where if you request a vehicle, they would want to sort of estimate which vehicle is closer to the person that is requesting the service. So that is also based on which cluster the person is and the vehicle that is nearest to them. But I can see there's a lot of other use cases for that. So let me just go into this color code for what we're doing. So we are using Spark, submitting it onto our Hadoop cluster. So the first thing we do is we import all the modules that we need for this model to work. So of particular importance is the clustering, which is the k-means that we're using. From there we define our object. As you can see here, we've got a date, which is a string, the latitude, longitude, and the base, which is exactly what I showed you in the other file. And then from there, what we do is we sort of define the structure of our array, and we're converting that to a timestamp. As you can see, it's coming through as a string with date. Everything else remains the same as it is. Then we load our data set into an array. Once we've done that, we are able to display the data itself, probably like the first 20 rows, and then even show the schema as well. The feature is what we need to submit to our model. So we defined telling it the feature columns are the latitude and longitude, which is the feature that is going to be used by the machine learning model. From there, we split the data. So like I explained before, we split the data for a training data set and a test data set. So essentially what we're doing is we're saying if the array 0.72 and 0.3 split of those records that are coming through. From there, we are able to define our k-means model that we're going to be using for this one. So we are saying set the points to 20. If you look closely on our map, we have those 20, which is exactly what we're telling our model. So we could have said now maybe set this to 10, because we don't feel like we want to cluster by more than 10. So depending on what you're trying to achieve, you would then change these numbers respectively, and we then call the features that we've defined, which is our latitude long, which is an input into our model. Once that is done, we fit the model to our training data set, and then this gives us the final sentence, which is the clusters that would have been generated based on that training data set. So from there, the rest of the model, what it's doing is we need to then output the results into a, for this one we are outputting into JSON files that we would then use to submit to then sort of mimic an IOT real-time representation of our data. As you can see, when we started to load the data, I did say push from a text file, which is as a result of combining the result that's coming from this model based on that. So essentially what you do is you train your model, then you apply that model on your data. So the data would now be outputted with a prediction that comes from the model in a JSON format, and all we're doing is we're converting that file into a text file. But obviously, if this is a real-time system, you would then use the same model on the data as it is passing through. But obviously, to make sure that your model is giving you the proper result, as you train it, you can refine the model just to make sure that you're getting the results that you would want to get from there. So the other portion of our, which is making us get this sort of output, is we're using Vertx for the presentation. So if I go to this application, you will see this is a basic HTML file. All we're doing is I've given it a name. As you can see, it says Lecton IoT, which is exactly what we have here as our definition. And we have brought in some input controls, which is allowing us to turn off and on the traffic and transit and weather, and even choosing the type of map that we have. So from here, this is the exact code that we're using for that. If you see, maybe if I go down a little bit, we've got the selector controls, and we think the selector control is the portion on our map that allows us to play around with what we see on the map here. We define the height, the length, and where we're placing it. And then this section, all we're doing is we are calling sort of JavaScripts from different areas for the usage in our application. So on the body, we are saying inside the body, what do we want to see? So we want the style selectors, which is exactly what we have. So the default I've set it to silver. This can be interchangeable based on what you want to do. And for the inputs, because we want to be able to click and control, so we have set these ones to input. So the map radar, which is got the value 10 off weather, 10 off traffic by default, 10 off transit. We're just defining them as inputs on our map. And then once we've done that, we go into our script for the map. So the map is the ID now that we have. And then in here we're defining our variables. So the map, the heat map, traffic layer, transit layer, all these are variables that we're going to use in our map. And then we initialize the points variable, we initialize the temp data, which is where the data points are going to be passed through. C count as well, we're initializing it in location. Once we get into the init map function, we're calling on the Google code for defining a map. So we just give it an element ID map. We set the center to Johannesburg, which is why by default when I load my application, I'm setting the map into this sort of specific area. So depending on where you would probably want to center your map, you would control that. The zooming level, I've set it to default to 13. Then we define also when we initialize, we're saying when you load the map for the first time, there should just be no data. So we then allow, as we start to push the data from our Kafka topic, it will then start to show in there. So we initialize also the heat map, and we say it reads from temp data. So when we then push data to temp data at the bottom here, it will start to reflect the data, and then we set it to map. So we're setting the heat map to map. Then we are also initializing the traffic layer, info window, transit layer, everything from here. Once we're done with initializing the map, we're then calling on our Vertx code to sort of start allowing the data to be passed through. So Vertx, as I have explained here, is a non-blocking messaging system that allows us to send messages from different parts of applications or services. I think most of our applications, we have issues where if applications are running, they might start blocking each other. but because we want this to be a reactive system and non-blocking, we are using Vertx for that. So we define the event bus, which basically looks at where is the data coming from in terms of our host, and the event bus is defined basically coming from our Kafka topic that we have established. So if you look, when I created, when I called the application, I did tell it where the data is coming from. So if I just go back, you'll see I said jar map stream, which is the fact jar that we are using, web, the port that we're using, and this portion of the command tells us exactly the Kafka topic that we are going to consume the data from. So that is the section which is used here at the event bus. Once we do that, we open the event bus and we can log, which allows us to actually see the transactions as they come through, and then we register the function using the data. So if you see data, we're coming with data from here up here, which is where the temp data is going to be sitting in. And then once we've done that, we're saying, okay, the message is a JSON parsing of the data. We define the cluster as the message CID, which is coming now from our machine learning module. So as the clusters have been defined, they've been given an ID, we are grabbing the same. So for our latitude and longitude, we're just getting the same for our from our message, and then we start to count. So in here we're saying if the cluster count is less than 1, which is the initialization, let's go and set the location to be 00, which just allows us to set the markers for our clusters. So what we then do is we're saying go and grab the position of the clusters and plot that on our map, label with a string cluster. So if you look quite closely, we've got the cluster ID, so we're saying this is the marker, go and label with the cluster ID. So for instance, this could be something for, let's say for instance, if you want to display how many, I'm going to think of maybe a parking system, a real-time parking system. So I might want to say, for each of my markers, can you display the number of open or available parkings in that particular location? So what we would then do is I would go there and label with the actual count instead of just bringing the cluster IDs there. So you could play around with this in terms of whatever use case you might have there. And from here, all we start to do now is as the data is coming through, we start to count. So we increment our counter and we log the message, and as you can see, this is the portion that is allowing us to actually see that detail coming from our map here in this section when I open my developer tool. And then we close off that script. Now in terms of controlling the way the inputs that we defined in the top, this is the code that we're just using to do that. So I'm going to go to the traffic. So we are saying for the map traffic, it's a function. When you click on it, the default value is turn off traffic. Then what does it do? So it sets the map to now. In terms of the traffic layer, it's being set to now. Otherwise, you turn it on, and then this is exactly how the function will respond. Now for the styles, I think I did show you on the map where we have the, you are able to choose if you want a silver sort of background on your map. This is where we come and define all those elements in terms of what the roads going to be looking like, what the color of the roads are going to be. If you've got highways, what sort of color that you need for that, the elements and the colors, everything that we define from there. So this is the portion that deals with that. So with that in mind, that's essentially how we've defined our application, which is allowing us to actually have this visual. So from here as well, you can apply your security controls so that even if the application is web facing, you wouldn't want everyone to have access to it. So you can also apply the security layer and the Vertx portion of your application as well. Now I think I did show you the code for the machine learning application. So essentially what I did is I downloaded Marvin, which allows me to build the fed jars to be able to actually use the same. So where we are submitting the jar here to create this, it means we have to create the jar, the fed jar using Marvin. So once you download the Marvin, install it on your machine, and then it will be able to show you what sort of version you have. And then I go into the same folder where my code is sitting, because obviously this code is sitting in a particular folder. So for my machine, it's sitting in the home, and then say Maple Spark machine learning streaming for Uber, and then I just create the application. Once I've done that, it means I will be able to actually grab the code from there. So it outputs the data into a target folder. From there, I just use the same. So this is the same Vertx that I then use to submit for my real-time application. I think for now I'm just gonna end here, and then we will continue with this topic. Thank you.